Welcome class. Today we are going to discuss about homogeneous equation. What is homogeneous equation and how is it used to solve differential equation problems? Homogeneous equation is a polynomial equation in which all terms are of the same degree. For example, below you can see that there are three types of equation which you can find all degrees of the following equation are in the same order. Therefore, homogeneous method can be used to solve this problem.
Homogeneous equations can be reduced to separable equations by either substitution below. Y equals to Vx or x equals to Vy. When we apply implicit differentiation, dy equals to v dx plus x dv or dx equals to v dx plus y dv.
For example, in the first question, x minus y bracket dx plus x dy equals to 0. In this case, we could see that the whole equation has a degree of 1. Therefore, homogeneous equation can be used. So, we could use y equals to vx. When we apply implicit differentiation, we would get dy equals to v dx plus x dv. Once we have gotten the following equation, we would sub the equation into our dy. Therefore, we would obtain x minus vx dx plus x v dx plus x dv equals to 0. We could see here that x minus y, the y is replaced with our initial unknown, that is vx. So therefore, you will get a whole equation of x dx minus v dx plus x v dx plus x squared dv equals to 0. Once we have gotten into this equation, we can separate them based on their derivatives, that is x minus vx plus xv to dx and x squared to dv. Once we have gotten this, we could bring to the other side so that integration could be made. So as the steps shown, we could see that x dx equals to negative x squared dv is both integrated. Therefore, we will get ln x plus c equals to negative v. Once we have gotten this answer, replace back the v with x and y, where v equals to y over x. So your final answer for this question will be ln x plus c equals to negative y over x.
For the second example, in a bracket y squared plus ys ds minus s squared dy equal to 0. All of these are in degree 2, so we can use the homogeneous equation. So in this example, we use the s equal to vy. Differentiate it, we got the ds equal to v ds plus y dv. Substitute that into the equation, we got the in the bracket y squared plus vy squared multiply with in the bracket v dy plus y dv minus in the bracket vy squared dy equal to 0. Expanded, we got vy squared dy plus y to the power of 3 dv plus v squared y squared dy plus vy to the power of 3 dv minus v squared y squared dy equal to 0. Plus and minus it, we got vy squared dy plus y to the power of 3 dv plus vy to the power of 3 dv equal to 0. Arrange it to the respect of dy and dv, so we get vy squared dy plus in the bracket y to the power of 3 plus vy to the power of 3 dv equal to 0. So take it the dv to the other side and take it out the negative y to the power of 3 out. So we got a vy squared dy equal to negative y to the power of 3. Multiply with in the bracket 1 plus v dv. Divide the whole equation with the negative y to the power of 3 and v. So we get negative 1 over y dy equal to 1 plus v over v dv. So separate the 1 plus v over v. So we got the 1 over v plus 1 dv. Integrate the whole equation, so we get negative ln y equal to ln v plus c. So we need to replace back the v with the s and y. So where v is equal to s over y. So we place it back. We got the negative ln y equal to ln s over y plus s over y plus c.